All right, so now that we've got our buttons here working, we need this menu to work. And it's just a simple fact of basically digging into our Python dictionary that's stored in our JSON file and listing the keys, right? Every project has a key, which is the project name, and we just need to list them. But there's also an additional step that we always want to include this kind of dash just as like a kind of like a null project, because sometimes when we drop down this scene data node in a scene that doesn't already have a project variable set, then we're going to basically need some kind of indication that we're on no project at all. We're sort of between projects. And then if we go and set to a test project, we would want it to go and initialize all the variables. So that's another later stage that we're going to get to. But then, besides selecting all of those projects, if we, once we've created those variables, if we dropped a node down and we already had project variables set, then we would want it to automatically pick up which project we were on. Okay, so these are all sort of steps that we're going to be working towards. So let's do that. We're going to be diving in not to our project tools, right? Because this project tools, remember, this is essentially the code for this shelf tool, okay? And yes, a couple of these buttons over here. But this is part of the scene data node itself. So let's specifically work on the scene data module that is going to hold all of the scripts for the scene data node itself. So all of the setting of the variables, all these paths and stuff, checking things and creating this menu, basically all the operations that this node is undergoing is going to happen in our scene data module. So let's go and create that. So let me just pull this in over here. So if we have inside of our scripts, we've got our utility scripts, remember? And we've also got our project tools. So we're doing exactly the same thing. We're now just creating a scene data module. Okay. Inside of here, I'm just going to do it the simple way. Now that I've shown you both ways, I'm just going to do it this way and show we're going to create our init.py so that it treats scene data as the module. Oh, whoops. Sorry, not a new folder, another new file, and then we go here, main.py. Right, now let's also copy this path so that when we go and open it up in PyCharm, then we can easily navigate there. So we're going to say open. I'm going to navigate to that, or actually, we're already here because we keep working in our scripts folder. So now over here, there's our scene data folder. You'll see it isn't a project yet, so it doesn't have that little icon, but we can just open this as a project. And let's open this in, let's say this window, because we are done working with our project tools, so we won't need that one, so we can basically just open it up here. Okay. And so then we've got our init.py and our main.py. Init, we're not going to do anything here because we don't really need to trigger anything when we load it. But then obviously under main, we're going to write our script. Now, our scene data node, the node itself, is going to need access to the JSON file. So we're going to do something very similar to what we had in our project tools, where we create the sort of a variable for our JSON file, and then we refer to that. We're even going to create that same read JSON function that allows us to just store the Python dictionary in a variable called data. And one of the other first things we're going to need to do is, of course, is import our Houdini module so that it doesn't complain when we try and reference it. So now we're going to create our proj list, remember, so this is pointing to our config file. Which in my case is just in this path. I'm just going to copy it from here on my other desktop. But so you guys can obviously point it to wherever your the config file is, or you can even copy this from your project tools. So we can even come here. We can go to open, come to project tools again, say new window, just so It's funny, you always think you're done with it and then you need to open it up again. So basically we're just redoing this section over here. Now, we could even go and put this, instead of this read JSON being very specific and looking for project list, if we wanted to, we could go and actually create our own little script and put this in the utility script as well. So there's different ways you can handle this, but in this case I'm just going to be doing it this way. Now you'll see here we've got a little error because it hasn't got the JSON module, so we do need to import JSON, and then that will go away. So we have now the ability to read our JSON file and store it in a variable, and we've got our config file. Same thing as well with this config file. Here we're just manually pointing to it, but really if you wanted to, and this sounds a bit strange, but we would actually have a single global config file which has a list of all of the other paths that we need. And so every script we have would just point to that one config file and grab a bunch of data, because then if we change where this one, our project list, goes, it would just change in all of the references. So it's kind of a way of unifying it. In this case, I'm not going to do that. We're just going to leave this as is because it's a lot smaller of a pipeline. But if you just start getting bigger, you need to kind of keep things all unified in one location, and you don't want to be explicitly listing a config file on every single script, because if we change the location of this, now we have to remember and go and change it in every single script. Okay. All right. So we've got our project list, we've got our ability to read that, and now what we're going to do for this menu, okay, so let's jump back into Houdini, and when we go to our type properties and look at our menu, we're populating it currently with a very explicit list, but we obviously don't want to do that, so we're going to remove these items from this list and switch over to a menu script. But in our menu script, I don't want to, again, in here have a Python script. We just want to refer to our Python module, and our module points to the actual module that is outside of Houdini. That way we can control it from outside without having to even jump inside of Houdini. So inside of here, we basically just very simply can say who.phm. Remember this, the menus is one area where we could use phm. We don't have to use the quargs node. So we can say who.phm dot, and then we would just call something like project menu or proj menu or whatever you want to call it, okay? Because we're on our project here and it's the menu script. So we're just going to create a reference to that. Now, obviously that doesn't exist in here yet, so we're just going to go and create it, okay? So you can call it whatever you want. I've just called mine project menu because it's the project menu script. Okay. Now, in this particular case, we don't really need the quargs, but what we could do, just in case we do need it later on, is pass the quargs in. Okay, so we actually feed it the quargs. Here we create a variable to store that quargs dictionary, and then we can pass that quargs dictionary out to our external script, even if we're not going to use it yet. Okay, we could actually do the same thing for all of our other callbacks and stuff as well. Is just pass the quargs and then make sure that we pass it into these functions. Okay, and these functions do need to be set up externally to accept the quargs dictionary, even if internally they do not use that quargs. At least later on, if we decide we need something like, oh, did they control click the button, or when they set the menu, what was it before, or something like that, whatever the information we can get from the quargs, we don't have to now go and change the HDA. We can just start using the quargs dictionary in our external scripts. So that's probably a good idea to do, right? So we can include that in there. Now we are going to need to reload our proj. Oh no, hang on, sorry, not proj. Remember, we're referring to our scene data. So up here, we're actually going to need to do an additional step. Basically the exact same thing, except that instead of importing from project tools, we're going to import from scene data. We import main as, and then let's just call it scene or something like that. Okay, and you can call it whatever you want, right? It's just giving it a variable, an alias. And then we're going to reload scene, and then in here we'll just say we'll reload scene as well. Okay, and then what we want to do is we're going to be running, so from our scene module, okay, which is our scene data. In fact, maybe we should call it scene data just to be a bit more explicit about it. Okay, I mean, it's up to you. So I'm just going to call it scene data. Right, so scene data dot, and then we want to run now, we're going to create another function in our actual scene data external script with the same name of project menu. So we're just going to do that, right? But again, we're going to need to feed it the quarks in here so that we pass it all the way through into this function. We pass it from this variable into this function, just so that later on, if we do decide we need it, we don't have to come and add that in. Okay, so there we have it. And in here, we're calling that. All right. Now, obviously right now, if we click apply, it's going to complain with a whole bunch of errors because it can't find that. So let's go and create that before we even go and click apply. All right. So here we are. We can define a function called project menu, and we need to allow it to grab the quarks dictionary. Right now, if we just do star quarks, what that's going to do is accept a whole bunch of different keyword arguments and then unwrap them. We don't want to do that. We just want to literally keep the quarks dictionary from the menu script as a variable called quarks. It will be a dictionary that we can then open up and grab information from if we want to, but we don't need it. Okay. And then inside of here, we can then run our script. Okay. In this case, just so that we can confirm that this is all set up and linked correctly before we start, coding in here properly, let's just return. Now, remember, a menu script wants it must be a list, right? It's not a dictionary or anything. What it wants is a list which has an even number of items in it. Okay, so the first item is going to be a token. The second item is going to be the label that matches that token, and so it needs to be a list that has an even number of items. Okay, so we're going to just return that as a kind of a test to see that if our menu script does not fail but instead returns just a single dash, then it means that everything is linked up correctly. Okay, so let's go through. We'll click accept. All right, now it says the name scene is not defined. Okay, hang on. So we must have accidentally been referring to scene. We have to click through a million errors. Here I'm reloading scene instead of scene data. Right, changed my mind halfway about what I wanted to call it and then forgot to do it properly. Okay, Python menu script must return a sequence of strings. Okay, and that's apparently not what it's getting. Oh, okay, so there is another issue here that we've done. So this script that we've got here, right? I'm gonna close our project tools. By the way, it's just getting in the way. So this script is returning this. Okay, but what does it do? It takes this list of an even number of strings and passes it into here. But this function here is not returning it. It's just running that function. Okay, so that value that's being returned is kind of just disappearing into the void. So we do need to, here, we actually have to return the value that comes out of this function in order for this to be returned correctly. And then when this runs that script, it will then return it. Okay, so here we shouldn't need to return because remember we have one line, so we will not return. We could, however, if we wanted to, we could say menu equals, but then we would need to say return menu. Okay, so we can do it either way. In this case, I think we're fine to just run that script in a single line, but then here we have to return because it is multiple lines. Right, and now when we hit accept, our menu should have just a dash. Okay, and we can go and even double check if we want to really confirm that it has worked. Let's go and fill in something like foo and foo with a capital. Okay, and then when we shift over here, when we click that menu, see it already automatically adds it in. Okay, so straight away it updates, and the reason for that is that when we click this menu, it runs that script immediately, and that script has a reload function in it. So immediately it reloads the module before running the script that calls and creates the menu, and therefore any changes we've made come through immediately. All right, so now let's jump back in and code our menu properly. Instead of just filling in an explicit amount, we know we need to return a string here. So what are we going to do? All right, so we need to read our JSON data, of course. Okay, so we're going to do similar to before. We say data equals, and then we say read JSON, and that's that. And now we're going to essentially add, every time we have a key here, we're going to add it to our menu, but unfortunately we have to add it twice, because remember we actually want our key and our values to be the same in this menu. Well, basically our tokens and our labels should be the same, because this is a string menu. You know, we don't have a token of, let's say, like 0, 1, 2, but then the label says, you know, like the actual project name. In this case, the project name is both the token and the label, so we just need to append it to this list twice. Okay, but we also want to make sure that we have that dash, that sort of null project value, just in case we can't find what project we were on. Then we automatically set ourselves to just be a dash. Okay, so what we're going to do is create a variable called menu, where we're going to store that list. And immediately we're going to populate it with just our null value. If you actually want to say, like, type none or null or nothing or whatever you can, I'm just going to use a dash. Okay, but now we loop through our list of data keys and just append the keys to this list, but we append them twice. So we're going to say for k in data.keys, which is our list of project names, we say to our menu, we append k, but then again to that we also append k, right? And now we have to return, remember we do have to return our menu. Okay, so now let's go see if that has worked. We jump back over into Houdini, click there, and you see already we've got a list of our projects, right? And then what value is this? Because you see we're selecting labels, but what value actually comes out of it? Well, if we drag this in and say eval, we'll see that the value actually matches that. Okay, so when we're on dash, then it is actually a dash. When we're on our for new test project, then that's the value that comes out of there, which means that not only are we selecting the labels, but when we in Python grab that value and evaluate it, we are getting the actual project name. And that's important because remember, we're going to use this project name as the key to grab the right dictionary, which includes all of the data that we want to come and set here, like our project name, our project code, the FPS, the path, everything. Okay, that's basically going to be our next step, is taking that data, and when we choose a project, having it trigger a callback which goes and sets all of this data based on the project name that we have chosen. Right. And now also I just want to point out that you see we are not using our quags here, but because we're passing it in at every stage, we're handing the quags dictionary over at the menu stage, passing it into our function here, passing it into the function here, and accepting it over here. That means that it's here and ready for us to use, and without having to change a single thing in Houdini, right, without having to save this node at all, we could come in here and, for example, go, let's just change it to print quags. Okay, so it prints the quags dictionary and then runs everything else that we've done. So then we jump back, and then when we click our menu button, you see that it prints our dictionary of quags. Right? Select something, click, every time I'm doing that, it's printing, 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 okay? So it has access to all of this. So later on, if we decide, oh, hang on, we actually need one of these things, like maybe node or something, or maybe our script multi-palm index, we don't have to go and change the HDA at all, and we already have access to it. So if you would like to, if you are planning on using these nodes in your pipeline, I would actually recommend that you go back and do what we just did here to all of these other scripts that we've already added in our, for example, add project. When we click this add button, it will have a quarks list. That quarks list can be passed in here, can be passed into this, can be added into our script, and then you don't have to use it yet, but you can always use it later on. Okay. So there we have it. So now that we've got our menu working, we're able to add and remove projects from here. This whole top section is working, but what we want to do is for this menu to actually trigger something. So when we select a project, let's have it now set all of our variables and set all of these. Okay, so let's do that. All right, so by now we should sort of be able to predict what we're going to be doing next. We know that what we want to do is, you know, when we select a project here, go and set a bunch of things. But the first thing we obviously need to do is set that callback and link it all up so that it runs a function in our script. That part is kind of always going to be the same, because once it can trigger something in our actual script, then it just comes down to writing whatever script we want. So let's do that. So again, we're going to come in here, we'll add a function in here, something like, should we call it set project, because that's what we're doing, right? So we're setting the project, and we'll kind of continue with this good practice over here where we feed it the quarks dictionary, whether we're going to need it or not. We're going to reload the module that this is contained within, which is going to be our scene data node, because remember this is on our scene data, and we're going to then want to run a function called set project on our scene data. So it'll be scene data dot set project, and we will pass it those quarks as well. We don't know at this stage whether we're going to need to actually return anything, and because this is not a menu script, the odds are we won't need to. So for now you can just leave it out, but obviously later on as we write the script, if you find that some data needs to come out of this, so it's not just acting and doing things, but also returning information that you need in this little script over here, then sure, you can go and add return or store it in a variable. Okay. And this set project function needs to be triggered by our callback. So when we run this menu, okay, when we actually click it and select an item, it's going to run the callback script, which is here. Now it looks like it's Python, but remember it defaults to HScript, so we're going to switch it backwards and forwards to force it to be correct. And then we are going to say who.phm, and then we can run our script, which was called set project, our function rather, and we will feed it the quarks dictionary from our callback. So the clicking of the button creates that dictionary, we pass it in here, we look at our Houdini module, and then we run our set project function. Feed it the quarks, reload, run our offloaded function, and feed it those quarks as well. So that's basically all we should need to do in here. But then obviously in our scene data, we need a corresponding function, otherwise it's going to throw up an error. So let's just create a quick one. I mean, no matter how confident I am in this process, I always first test just to confirm that it is correctly linking and doing something, because then you feel totally solid in writing a giant script over here, and then you know that it should still work. The problem is when you go and you don't test it, you build a script, it then errors, and you assume that the error is in your script, and it's not. It's maybe just in the way you're running the callback. So it's easier to just test it this way. So shall we do something like just print our quarks? It's just a nice and easy way of figuring out that this whole process is actually linked up and working. Okay, so we go over here, we drop down the menu, and we select something. Okay, and if we just give it some space here so we can confirm, that is exactly what has happened. Every time we click that, it runs the function. Okay, so let's go and write our script now. So what we're wanting to do here is set a bunch of variables. Now we still need to go and do the additional step of setting all of these parameters to have Python scripts that read all of the variables, our $project variable, for example, and $code and $proj FPS. But the ultimate goal is that essentially these are going to be variables, environment variables. So calling $project would call that. Okay. At the moment, there is no such thing as $project, $code, and you know, all of these. Okay, all of them in this project folder. Okay, we're not looking at scene yet, just project, but these we should all be able to set. We already have 4 of them because we've already asked the user to define the path, the FPS, the code, and the project name. The scenes path, HDA, and scripts are sub-paths of the project path, and so we can implicitly calculate those as well. So we actually already have all of this information. What we need to do now when the project is actually set is we need to go and set the variables, right? Which will also include unsetting the variables from the project that it used to be, you know, including like if we go and set to nothing, to a null project, we need to unset all those variables so that they do not have lingering values from a project that they are no longer a part of. Okay. So let's go and do exactly that. So the first step I'm going to do in here is obviously try and just read in our data, okay? Because that is exactly what we need, right? So we're going to want to run our read JSON, right? And store this as data, okay? And then what we're going to need to do is basically from our data, we need to extract the current project that we have selected, because from that menu, we are picking one of the projects, right? So we need to essentially point to data, but then feed it the key, and that key should be the actual name of the project, right? But how do we get the name of the project? So we're kind of working backwards here. So let's call this, let's just say proj name, or let's give it the full one. Let's say project name, just be a bit more explicit, right? Now, obviously, this variable doesn't exist yet, but we're going to go and create it. Okay, so project name equals, and what we're wanting essentially to do is just evaluate the current value of this node. Okay, so remember in our quarks dictionary, we do actually have a value as well, so we could evaluate the script value from our quarks. Or alternatively, we could evaluate the actual node and use the quarks node. So for example, we can say node equals quarks node. And then in here go node.eval_parm, and then we know exactly what the parameter name is, which is proj, because that is our actual the menu name, okay, the name of the parameter. So we can do it that way, or alternatively, we can actually just set the project name to be equal to, so I'll disable this line. I'll show you both ways so that you can do it either way that you want. We can say project name equals, and then we say quarks script value. And either way, that will return an actual string, which is a project name. We then go and read our JSON data, and then we go and select that, well, we feed it that project name as a key into this, right? Now this is complaining because it says a statement seems to have no effect. That's because we're not storing it in an actual variable. So we're going to go and store this. We're going to call it project data, okay? Because now this is not just all of the data, but actually the data from the one project, okay? Now I want to do an additional step over here, which is, oh wait, hang on. Before we move on, I'm just going to show you this here where I'm referencing a node. At the moment, node is not being used, but there is a good chance later on that we will need to refer to our node when setting things, okay? So you may or may not need this line, Okay, what you can do is disable it for now. If you're going to go this method of using the quags script value, right, then you can just disable these 2 lines, but don't remove them yet, because later on you may find that you need the node, and so you can just come and re-enable that, and then you have a reference, a handy reference to the node that this is being triggered on. Okay. Alternatively, if we don't go for this script value method and instead go for node, then, well, we definitely need to use node because we're using it over here. Okay. So you can go with whichever way you want. Now, what I want to do here, when I grab my project data, although we should be fine, like honestly, the menu is populated based on a list that came from the dictionary. But what if somehow that parameter is fed a string that it doesn't have here? We maybe force it to have a string that isn't in the menu, right? Or a menu item is removed or something like that, you know, like the JSON file is edited while we've selected it or something like that. So we can have some weird errors occurring. And so we need to be a little bit careful here when we're grabbing keys from a dictionary, right? If it doesn't find that key in that dictionary, it will not just be quiet about it, it is actually going to error. And errors can obviously cause things to break. Errors are useful to us because they tell us exactly what's wrong, and of course we need to know when something's wrong. But we don't want it to break the script, we want to just handle those errors correctly and say, okay, well, if this error occurs, then let's do this. It's kind of like having a backup plan if something goes wrong, as opposed to just when something goes wrong, then everyone freaks out. Okay, so what we're going to do here is say try. So try do this. And if that fails, so accept, but we want to give a very specific failure. And if you're not sure, then always come and check. Okay, you can Google these things, or you can just double check it yourself. You can come and create a dictionary called mydict, and we'll just give it a, we'll say foo, and the value is 1. Okay, so just a very simple dictionary, but then what we do is we try to call a key that is not in that dictionary. So just something, right? And you'll see it spits out a key error saying that that key does not exist. So that is the type of error that we want to accept, right? I've told you before, you can put an accept with nothing, but even PyCharm here is going to say, whoa, you don't want to do this. This is too broad of an exception clause, okay? Because what if something goes wrong and you didn't kind of account for it? So you never want to leave it just, oh, try accept. That's really bad, okay? Instead, we want to give it our key error and say, right, if you specifically fail in that way, then this is the backup plan, right? And the backup plan here would be to throw up our error. So remember, we need to actually access our utility module. So we can say from utility scripts, import main as util, and then also let's reload our utility script just in case. Now over here, we would then say util.error, and then we'd feed it a message. Okay, so some kind of error, like some error message. So we say that the project data not found or something like that. Okay, and then of course we need to do something about it. Well, we can't continue with this script without that information. So what we do is we return from our function. So we tell them something went wrong, and then we stop doing everything. Okay. But assuming that we now get through this part where we have our project data, which would be essentially a key, well, a key value pairing of code and code, path, and FPS. And then our project name is not one of those keys and values, but we already have project name because it's the value of our actual menu. Okay, and because it passed this check, we would know that our project name is actually a valid project name and does exist in that dictionary still. So we have all our 4 bits of data. So now we need to just go and store these as variables. And remember, to store an environment variable, we just use who.put env. Okay, So there's get env, there's put env, and then there's unset env, right? These are the three that we're going to use to create a variable or overwrite one, to fetch data from a variable, and to remove that variable entirely. Okay. So here all we need to do is feed it the variable we want. Now we don't give it dollar something. The dollar is implied. The H script uses dollar as a way to call that environment variable, right? But the name is just, you know, everything without the dollar sign. So in this case, what we want to do is set a variable called project, and this is going to be the project name. Okay, so we're going to say project name, which is this variable over here. Okay, so we're going to create that variable. We're also going to say who.putEnv, and then we have our code, and we're going to feed it. Now here's where we're going to grab our project data, which is that dictionary attached to our project name, and feed it code. Okay. Then we want to do the same for FPS, but with FPS we also want to go a step further. We don't just want to store this as a variable, we actually want to change our scene file. We want to set it to have a different FPS, because if we're changing to that project, we need to take on that FPS. FPS doesn't help if it's just a variable. It needs to be set in the Houdini scene. Okay. So step one is obviously just create our variable. So we say put env, and then we set proj FPS. Now remember, I specifically put proj here because we just want to be careful that we're not overriding the actual, like, another FPS variable that Houdini uses, okay? Particularly because Houdini might override it for us. So we're just being a little bit sort of explicit here. And we want to feed it our FPS. So we would go project data FPS, right? But remember, this is coming to us in the form of an integer, and these variables will only take strings, okay? So we need to convert this to a string. But then, you know, and remember, okay, so it stores that as a string, but when we call an environment variable, you can then call it and convert it back to an integer. So don't get confused by that, but these environment variables will only accept strings. So we have to kind of convert it just to store it in here. Then the next step is to say who dot, and then there is a function in Houdini, set FPS. Okay, so we can check that in here, or you could obviously check in your help file, but I'm just skipping ahead here. We're saying who dot set FPS, right? And then we can set our FPS to be whatever we want, and we just need to give it the FPS that we want it to be, and it'll change our scene to that. Okay, so we want to do that, but because we want it to be set to the same value, okay, but just not the string version, it would be better to actually, instead of feeding it in like this, is we would just create a variable. So we're just going to call that FPS, and then here we're going to say FPS equals, because then in here we just call that same variable. So we want to call our data only once and store it in a variable so that we can just refer to our variable twice. Okay, so there we are. So now we have we've set our project name, our code, our FPS, and then we obviously need to also set our project path. Okay, so we're obviously going to grab our project data and get path. So that's the variable we're going to want to use, right? So we're just going to go here and say who dot put env, and we're going to give it, we're going to call this one project path, okay, and then give it that as a variable, okay, project data path, okay. Now if we go to here, I just want to show you where I'm getting all these variable names. You can obviously give it whatever variable name you want, although you need to be careful not to overwrite things, but I'm specifically giving it these names that are here that we've chosen as the labels, okay, so that the variable actually matches the label. So project is the project name, code is the code, proj FPS is the FPS for that project path. Okay, so if you want it to be consistent, where it's all either the full word project or just proj, or maybe all of them should have the word proj before them or not, whatever, it's totally up to you. Just make sure that it is consistent though. You don't want this to say project path, like $project path, but then actually it's $proj path or something like that. Okay. All right. So now that we've set all of those variables, we want to also set these ones at the bottom here, the scenes path, the HDA path, and the scripts path. Okay. Now that is coming from, so let me show you here when we go to our projects. So for example, in Python over here, you'll see I've got this kind of set up already. So we have a scenes folder inside of here, which stores the whole list of all of our scenes. Okay. So as we're working on a scene, we just create a new scene in here and it will store it in this, and we can work in there. Okay. So this is the main root folder that will store all of our scenes, and it is under the root, but just /scenes. Okay. So we're going to use our project path, but just append an additional scenes folder to it. Our HDA folder is exactly the same. It's still in the root, but it just needs HDA appended to it. And then in here, these will be our project HDAs that are very specific to our projects. And then we also have a script path, which again is in this root, but just scripts. So very, very simple. We're just appending one additional path to the end of our project path. Okay. Now, obviously, that is quite obvious. So why are we setting it as a variable? Well, the thing is, sometimes you just want to refer to that variable and you don't want to have to remember that, okay, hang on, what is the actual project, like the folder structure? Is the scenes path one level down? Is it specifically called scenes? Is it a capital S, a lower s? And that can make a difference. So storing it as a variable means that we can just refer to it when we're, let's say, writing out a new HDA. You just use $HDA path and you don't have to think about where that is. Okay. So let's come in here and we're going to set those as well. So we'll start with our scenes path. So we're just going to say who.put env. We're going to call this scenes path, right? And then what we want to give it is, so we're going to want to join two paths. So we'll essentially join an additional string as a folder name to a path that we already have. And there's a very simple way of doing that, which is os.path.join. Okay, so we've already done this function before, but we haven't imported our OS module. So let's come up to the top here and just import OS. All right, so now that is not complaining. We need to feed it our path, but instead of having to call project path again, let's create this as a variable instead. So I'm going to remove it from here, call this path, okay, and then, or maybe we should call it project path. Let's be a little bit more careful with the naming, okay. And then over here we'll say project path equals, and then we feed it that, right? So same thing's happening, but now because we have a variable, we can then just go and call it in here as well. And we're going to take our project path and then append it to just a string, which is going to be the folder name scenes. Okay. Now we are obviously at this stage assuming that there is a scenes folder. We are going to account for that later on. If there is no scenes folder already created, we are then going to trigger the creation of that folder. But for now, that's okay. Let's just assume that there is a scenes folder. Okay. So we do that for scenes. Then, oh, but hang on, there is something else I want to do here. Remember, we even came across this earlier. So we built a script that goes and fixes paths. Now, when we do os.path.join, this is going to use our separator. So on Windows, for example, which is what I'm on here, our project path might use /, but then to join the project path to the scenes, it's going to be a \. Okay. So let's just, once we've created this entire path and joined it, let's fix our path. Now we have imported our util function, our util module. So we go util dot fix path, and then we just feed it that path, and it will return the fixed version. Okay. All right, now let's move on to the HDA path. So we're going to now do who.put env. Same thing, we're going to do HDA path. We're now going to, okay, so here we're going to do the same thing. In fact, we're basically going to do the exact same thing as this, so we might as well just copy paste, but instead of scenes path, it's just going to be HDA path, right? And then in here, we'll just swap this for HDA. Okay, and then the same thing with the scenes path. No, sorry, not scenes, scripts. Okay, so we're just going to swap this for scripts path and scripts. Okay, because they're all one level in, so we're just appending one to it. So we start with project path, and then we just go one level in: HDA, scripts, and scenes. Okay, so there we are. Now let's test this before we actually move on, because you know, we've done quite a bit. It's always good to maybe stop at a certain point and double check that what we've done is not actually breaking anything. Okay, so let's come back to our scene here. Now we know that this was all linked up already. We're no longer printing our quargs, so when we click on here and actually click on the node, right, right, it's actually strange. Oh, it won't have changed because we're just clicking this. Hang on, that, I guess we need to probably select one for it to run the reload. Okay, so let's just double check that this is working. No, something is still printing quargs. So let's have a look for that. So nothing in here is printing it. In our project menu, we're still printing quargs. Okay, so let's remove that from there. Okay, there we are. So we go and set a new project. Right, now nothing seems to have happened, but let's have a look at our variables, because that's actually what we've been changing, is our project variables. So we come over here. Now what are we looking for? We're looking for one called project. So there we go, project 03_testproj. Right, project path is another one of them, project FPS. What else did we have? Code as well. Code is up here, code. Okay, and that's our weird random letters and numbers, right? Okay, so those all seem to be working. Let's check our scene path, HDA, and scripts. So HDA path is where we'd expect it to be, and then under S we've got our scenes path and scripts path. Perfect, and you see they've all got forward slashes. Everything's totally fine. Cool. So there we are. That section's working. Now let's move on. So once we've set these variables, we also need to do some additional work, because okay, our scenes are just going to be saved in that path. That is something that we're actually going to deal with later on, whereas we're going to be building some additional scripts and a saver script that deliberately goes and saves our scene with a very specific naming convention and all of that kind of stuff. So we'll get around to that. But immediately there is something that we can do, because remember our 123.py script and our in our 123.py we're loading our HDAs, our HDA paths, and appending them to our Houdini OTL scan path variable in Houdini. Okay. In fact, I'll just remind you, I'll show you here our Houdini OTL scan path. Okay. But what we want is this. So we've got our root, which that's where normal HDAs should be stored, is $HH/OTLs. But we've appended our global HDAs path to this. But when we set to read this project, we want that project's HDA path to also be added to this separated by a semicolon. So that's one step that we need to do. Another is that our path variable, right, which has a lot of semicolon separated paths, right? You'll see it goes on for ages. These are all locations where we have scripts that we want to be called, including these scripts that we're currently reading now, because if we look through this path, we'll find our global repository, which has our underscore Houdini in it, right? I'm not immediately seeing it, it's not jumping out at me, but you know, basically it's in there, okay? So what we want to do is go and append to that as well, so that our project HDAs will be scanned and our project scripts will be scanned. Now the scripts doesn't matter, because as long as it's been added to the path, when scripts are called, it will then check them. But with HDAs, we actually have to force a reload as well. Okay, so that's what our next steps are. So let's start with the HDAs, right? So, sorry. All right, now we're going to need to get our current value from the Houdini OTL scan path, because we want to append to that. So, and there is no simple way of appending to it. There's no script or function that just appends. So we need to actually take the current value and sort of strip it down, add to it, and rebuild it. Okay, so we're going to call this scan path, right, where we're just going to store this, and we're going to go who.getEnv, and then it is spelt exactly like this. Now you need to be very careful. It must be exactly this, okay? Houdini OTL scan path, right? And that will fetch the current value for this, all right? Now we need to double check that this has actually grabbed something. If that, for example, if we try and get a variable that doesn't exist, let's double check what will happen. So let's say who.getEnv and just give it a random variable that may or may not exist. It doesn't error, it returns nothing. Okay. In fact, if we went back here, stored it in a variable, and now print var, you'd see that that prints none. Okay, so that's important to know. We don't have an error to escape, but what we can do have is we can say if scan path, right? So only if it has actually found a scan path already, then what do we want to do with this? All right. So what we want to do is we want to take our scan path and we want to split it at all of these semicolons, right? Because we know that this is a list that is separated by semicolons. So if we do the split function and split it using semicolons, we're going to get a list of these individual paths. Then we can add our new path to that list, and then we're going to rejoin with semicolons. Now this is a little bit of a longer way to do it. Technically, the scan path is just a string. We could add a semicolon at the end and add our path to it. But that's not the right way to do it, okay? This just takes a few extra lines, but it is much safer. For one, we can make sure that the path is not already in there, and also we don't want to have things where we may accidentally have double semicolons in there or something like that. So we really want to strip it right out and then rebuild it using semicolons, okay? So in order to do that, we're going to actually need to create a list where we're going to store these split things, okay? So we're going to call this list HDA paths, right? And now, instead of creating just an empty list though, we already know one path that needs to be in here, which is our actual HDA path, okay? But our HDA path is here. Right, we've fixed the path and we've joined it to that, so we know that this is actually that path. So we're going to take this entire thing, call this HDA path, and store this in a variable, right? So take that same thing, store it in a variable, call it here, because now we're going to call HDA path inside of here. So we essentially are creating one variable, which is a list that stores a list of paths, but we already know one path that we definitely want to be included. So we're going to start with that in the list, right? You don't necessarily need to put the comma, like we don't have to go comma and then put nothing after it, but you can if you want to. Either way, it's a list with one item in it. But now, if we find that the scan path, the Houdini OTL scan path already has some items in it, then we're going to split them by semicolons and append them to this list. Of course, if it finds that this variable doesn't exist at all, then we're just going to still go and set it, but just to be equal to this list. So we'll only, if there is something in here, then we'll get past it, this check. Okay. So now we say HDA paths, right? And then we're going to dot append. And then, oh no, actually, we don't want to append, sorry. If we append a list to another list, that it'll just add that list as one item in here. So for example, it'll look like this. Okay, it'll be one item and then a list of items, and we don't want that, so we just want to add them together. So we're just going to say plus equals, and if you add two lists together, they just join themselves. Okay, so that's one way of many to sort of join a list. So now we join the list, so now our list should have actually technically three items, because it's got this. Then we know we're going to have $HH/OTLs, and then we also know we're going to have our global HDA repository already in there as well. So we should have three items in this list. And then we want to double check whether there are any duplicates in this list, or we're not really checking whether there are or not, we're just ensuring that there are not. So there's a simple way to do that, which is to take our HDA paths list, okay, turn this into a set, because remember, sets cannot have any duplicates. Then turn it back into a list, because obviously we want to work with it like a list. We want to be able to call indices from this list instead of having to loop through it. Okay, and we're just going to store this back in the same variable that we had it in. So HDA paths equals, and then we just take it, turn it into a set, then turn it back into a list. In this way, we ensure that if there were any duplicates in there, maybe our HDA path that we're trying to add was already in this list. Okay, well then we've now gotten rid of it. And now we just want to go and store that variable. So we say who.put env. We specifically want to overwrite Houdini OTL scan path. And what are we overriding it with? We're going to override it with, now remember, we need to give the string of the separator, and on that string we run the join function. Okay, and we're going to just join the whole list of paths. Okay, and now because we've added to our Houdini OTL scan path, the very final step is to just reload our HDAs. Okay, so we say who.hda. Remember, we have an HDA module, and one of the functions in that is reload all files. Okay, so there we are. So let's test this before we move on to our script. So we're going to go back in here, and then let's go and set our let's go set to this one. Okay, so test project, right? So we've clicked the button, which means it will have run our script. We can go and check for our variables. Now, obviously, it will have created our variables, the ones that we've already checked, like project and code. But what we're looking for is Houdini OTL scan path, and you'll see that this scan path now includes our global repository, which has that underscore HDA. Underscore Houdini. We've got our $HH, which is the global one that Houdini expects, and we have both projects, because I clicked on each project in turn, and it will have added it to this list. Okay, we do not have anything yet that is removing them from this list, but at least we have them being correctly added. right? And also it will now have loaded any HDAs that are inside of those two project folders, right? So in this project folder, in a folder called HDA, it will now, any HDAs that are found in here will be scanned in our Houdini, okay, which is pretty cool. So we are going to obviously go and add a way to go and remove, because when we switch away from, let's say, project 4, our new test proj, then we just want to remove that from this list, okay. And then we're going to do scripts next. Okay, so with scripts, it's a lot easier than this, because we don't have to go and do, like, basically all of this is handled by one very easy function, which is just that in sys, which we do need to go and import, but it's sys.path.append, and then we can just feed it the script's path that we want to append to our path, okay, and that will appear. Well, I think it should appear in our path variable, but either way it appears in our actual computer's environment variable called path, which will have a list of all of the Python paths that need to be scanned. Okay, so if we just go sys.path.append, but obviously here we need to actually import our sys module. And by the way, if you click on here, you can actually click import sys, and it will go and add that to the top here. So it does that for us. So sys.path.append, and then we want to feed it our scripts path, but obviously we want to do the same thing here and kind of store this in a variable. So we take that all away and we call it scripts path. Store that, and then just append scripts path to our path. Now, it is true that in this case we're not checking for duplicates, so if there were duplicates, we would just be appending to it. You know, maybe that's not great. It might be worth checking whether it already exists in there, but you know, in this case, we can just leave it. If you want to be much more careful with this, you can go and first double check. You can actually go and read the so you do who.getEnv and go and grab path. Check whether this script path exists in there, and only if it does not, then you could append it. All right. So you can go and add that in as an additional safety feature if you'd like. All right. So the final step now is going to basically be going and unsetting these variables when we change projects, right? Because if we go and set ourselves now to this null project, okay, obviously it's going to complain that project data is not found, right? So that's actually something that we should account for, is the fact that this null project is not. So maybe we go to our script and find some way where we. Okay, so it's complaining the project data is not found, but maybe what we should do is before this, we should check if it's just set to a dash, because if it's set to dash, well then we don't really even want to complain because we know they're setting it to be a null project, okay? So you could do something like that. We'd just say something like if project name equals dash, then just return, okay? Or I guess, well, let's go and add in our unset, because we may need to figure out where to add this specifically, because if we do set our project to be nothing, like set to the null project, so we go and set and then we set it back. Sure, we don't want it to complain, but we do want it to go and unset all of our variables, right? So for now, we'll go and disable this line, and then we'll think about where to place that in, right? But what happens, see, here I want to go and, this is where we're setting our variables. When we change projects, before even setting the new ones, I want to go and unset the old ones, just to make sure that we're not, accidentally appending or doing any weird things. We want to be very cautious and go and remove every variable that we have and then set it to be a new one, okay? It's not strictly necessary, but I'm just trying to be very cautious here because we're building pipeline. Some things can break, and when they do, it's better to have stuff happen in a very specific and controlled way, right? So All right. So we're gonna basically say if, in fact, you know what? I don't think we need, okay, when we do set project code, whatever, we are overriding, so any project should be fine. So the most likely scenario, though, I guess the only one that really is a concern is if we have a project name equal to dash. So what we'll do is inside of this block, we'll go and unset all of our variables. But if it's not set to dash, then it will just override them, and that should be fine. Okay, so let's do it that way. Sorry. So simple function who.unsetEnv, okay, and we then just point to the variable so that it then goes and removes it. It's literally just deleting a variable. Okay, so we've gone and set project, we know over here, so project is one of them, so we're just going to unset project. We're going to unset code, we're going to unset proj FPS, right? Maybe we should even go and set our FPS back to something default, like maybe 25 or something, whatever you consider to be the default. I guess it depends on which country you're in, or which types of projects you work on and what you normally use. We would say we would unset. What do we have? We've got project FPS. We've got project path, right? Who.unset, and then we've got scenes path, HTA path, and then finally scripts path. All right, and that's just so that basically when we set this to just a null project, we remove all of our variables. Okay, but what is also going to happen is when we drop down the node first, if it doesn't detect any of these existing, then it's going to set itself to a dash, but then that will automatically go and clean things up for us and set us to a kind of a neutral state. All right, so this should basically be enough. So now we come over here, we can test it out. So we set to test project, right? And we'll come in and have a look and see what our variables are. Just double check that they're here. For example, project FPS, project path. Okay, they're all set there. Now we go and set to that, right? Okay, oh, hang on. See, it is, because we took away the return, it's doing all the unsetting, but then it's actually continuing. So it's attempting this, it's hitting this error, and then it's returning. We don't really need to do that, so we'll just throw in a return at the end here, because we know that setting to a null project doesn't really require us to error out. Okay, the user is not assuming that dash is an actual project name. They're saying set to nothing. Okay, so when we go and set it to nothing, it won't error. But when we come under our variables, you'll then find that project should be here, but it is not. Okay, all right. So then final step for this is we can actually take this whole section here, this project section, and go and set these parameters. So here that we would set this to a Python expression where we would say, okay, sorry, let's change script language first. And we would set this to be who.get env project, right? So currently it's none, but obviously when we change that, then this, that's interesting. Why is that not working? We should have a project variable now. Project is that. Let's set that there. And unset. Okay. Do you know what we'll need to do then is actually with our menu script is we'll have to maybe force recook our node, because if we do set to this and we say .cook and we set this to true, then it will recalculate the node. So what we should do is on the callback of our actual so when we say set project, which remember is kicked off when we actually call back when we set the project, which is when it's going to do all of this, we also want it to force cook the node, okay, so that it kind of rejigs all of the variables that we've gone and set, okay. So obviously we want to go and set the variables first, but then at the end, then let's go and add in a so our node. So there's our node reference. So remember, if you've done the this method of using the script value for the project name, you'll still need to use quargs node just to have a reference to the node. So we'll say node.cook true, just to force it to kind of figure itself out again, because we've, as we set variables, we want stuff to update immediately, right? So there we go. See, now as we click that, it now updates our variables immediately. Okay, that's much better. That's more like what I'm expecting. Okay, so same kind of thing here. We can paste expressions on all of these, right? Which at the moment they'll all be the same, but then we'll go and just change their expression value that they're looking for, and then we'll go and store these as defaults. Okay, so this shouldn't be looking for project, we're instead looking for code. This should look for proj FPS. This should be project path. This should be scenes path, HDA path, and finally scripts path, right? And each of them should then be pointing to exactly what we'd expect to see. But then we come to our asset, and under each of these, so all of these over here, we would come and I think you can actually multi-select them. Then if we right click and say copy defaults from node, it will go and set the channel to be a Python script, and we'll have it take on that code already. Okay. And the cool thing with Python scripts is actually by default it doesn't intend to show the script, it tends to show the value of the script, which is why I prefer the Python ones here instead of calling the like if you called $dollar project or something, right? It should, if we middle click, it should result to test proj as well, but the problem is you have to actually scope it like this, whereas running it this way by default will show the value. Okay, so it's just better that way. Right, so there we have it. Now as we adjust this, it adjusts all of our variables, including here this should unset it. Oh, hang on, that's another bug. You see here, it changes automatically when we set these, but when we do that, it doesn't seem to update these. Okay, and that's because it's not doing the recook over here, right? So when we're done with this, we do our node cook true in here, but we also need to do it before returning from this, right? So now when we come back, we'll set there. When we set to that, it'll jump to none. Okay. See what I do, by the way, this testing process of like actually coming and doing, like writing your bits, like the scripts, and coming and actually fiddling with the tool, like just clicking the buttons, trying to break it or trying to do stuff. This is how you're going to write your scripts most of the time. You're going to figure out what's working and what's not by, actually messing around with it. Okay, simple things like having to force recook it is something that you wouldn't know until you actually start playing with the tool and saying, well, that's not nice. I'd expect it to update immediately. So now how can I force it to do that? All right. So that was quite a meaty one, but there we are. So now that's all working, and we have the ability to now set new project and then go and actually set to the project, and it sets all of our variables. So now we can call those variables. We've got our FPS set. So if, let's say, we go and create a new project that has 30 FPS. Okay, so let's go and remove our test project. Go and create a new project using that. We have a random code, but we set our FPS to be 30. Then in here, when we set to new test, our project FPS will be 30, but if we come and check over here, you'll see that our FPS is also 30. And we set ourselves to test project, and now we're on 25. Fantastic. Okay. All right, so thanks everyone, and I'll see you in the next lesson where we will continue with this.